are you so late?
Sorry, I missed my bus. Really wish I had a car.
Why don't you just buy one?
I would, but there's just so many things I have to consider.
Why don't you use the online dealers?
Because they offer like hundreds of cars, and I just don't have the time to pick one.
Oh, I have the perfect solution for you.
AutoSmart is an intelligent decision support system that allows users to input exactly what they're looking for when they wish to purchase a vehicle. Based on their inputs, the program will provide them with a list of vehicles that best suit their needs. Users can select a budget range from between $5,000 to $100,000. Users can select the number of seats they wish to have, ranging from 2 to 7. Users can select an estimated kilometer range that the car may have already been driven, from 0 to 200,000 kilometers. They can also indicate how long they wish to own their vehicle, from a minimum of 1 year to a maximum of 10 years. Users can also indicate if they want a new or used vehicle. Once users indicate their preferences, including the budget, number of seats, estimated kilometers, planned length of ownership, as well as if they want a new or used vehicle, they can click Search. They will be directed to another page, which displays a more relevant and simplified results page. This page lists vehicles that suit their needs. They will have full access to an in-depth description of different categories related to exactly what they listed in their preferences per vehicle. Examples include the color of the vehicle, the number of passengers it can hold, as well as the fuel type.
Talking about the scripting that we use to get data off of AutoTrader and allowing ourselves to input it into SQL to use it as our own database. These three import statements here, file IO, are all for taking the data that we extract and importing into the CSV. These three here in Java.util allow us to use arrays for my own personal preference. And these 5 for Selenium are the engine that we use to go through websites and manipulate them and extract data from them. So Selenium is a language agnostic system that allows us to drive browsers. In this case, we're using the Chrome browser, so we're using Chrome. As you can see here in the system.setProperty, I give it the statement that we're using the WebDriver for Chrome and where the Chrome driver is, and it works. Here we have a print stream, which allows us to print straight to a CSV called card database, and using that setup, we print this tuple, which contains the column headers for the CSV, and this will go straight into SQL later. Here we have the WebDriver being instantiated, and now I take this URL, and by using driver.get, I tell the driver that I want it to navigate to this website, which is the main AutoTrader landing page. So what the script does is that it goes into location, input an arbitrary postal code, and it also sets the 50-kilometer radius, and when applied, this gives you a bunch of cars in that radius based on that location. So the script will then take every single link on this page, copy it, commit it to memory, then for each link, navigate it to its own tab, take this title here, take this price, and take everything in the specs. And then when it's done, it'll move on to the next page and continue doing this ad nauseum. And you can see here, click the filter button, click the location, postal code, set proximity, this was 50 kilometers, apply the changes, and then arbitrarily click on the title so we can actually continue, get the links, and then for every link inside of this collection of links, we verify that it's a year so we can prove that the link is actually for a car. Then we take the URL, we take the URL, and then based on that URL, we run get specs. Get specs what it does is, based on a URL, it creates its own separate WebDriver. We find all of the specs. We clean them all up so they don't have commas, so our CSV doesn't split based on those arbitrary commas. And then we output these specs. And then, as you can see here, we continue with this ad nauseum until we get as much data as we want.
After the script outputted the CSV file, we put the data into an Excel sheet for cleaning. Since missing values were indicated by dashes, we wrote COUNTIF functions in Excel to determine how many data points were missing from each data category. For some values, it was okay to leave them as is, since there weren't too many points missing. But for others, we needed to change them or estimate their value. The missing integer values were changed to 0 in order to be able to import into the database without problems. For the passengers field, we recognized that this was a more important field that we needed for our query, so we used the body type field, which had little data points missing and only about 20 unique values to calculate the passengers. In the end, a large nested if statement was written to leave the value the same if it wasn't 0, and to use a value that was previously researched based on the body type field if it was 0. When importing the data into the database, we faced some issues due to encoding, so we kept getting errors when we tried to import the CSV file. So for example, the trademark symbol and characters with accents were not able to be put into the database. To solve this, we just replaced or removed those values.
Cars matching the user's preferences are done through this query, which extracts data restricted to the user inputs on the main user form. The data warehouse automation is based on modeling exactly what information is needed to produce for the users. The script implements the automatic design and best practices methodology used to extract the required information. Data is automatically extracted and put into the database for automatic usage in real-time updates. The data warehouse allows for real-time data updates and analysis. We are pulling data in real-time weekly updates from AutoTrader and pushing it to our database, which will be automatically populated into our results page once the user enters their requirements. The types of analytics used are descriptive, predictive, and prospective. The current database incorporated reporting car information, analyzing the different categories of all the extracted information, predictive approaches on how to allocate results based on user preferences, as well as operationalizing and activating the final results to generate a final response that the user can use. The scalability of our data warehouse grows linearly with our database inputs extracted from AutoTrader. Hence, the amount of data in the warehouse, how quickly the warehouse expands, as well as the number of users and inputted complex information is well balanced and scaled for efficient usage over long periods of time. Data is extracted from a reliable source, AutoTrader, and heavy emphasis is always put on user security and privacy.